There. So, in this chapter, which is the chapter 3 of grade 9 mathematics syllabus, the fractions, we're going to look at that today. Fractions are pretty easy, to be honest, but let's get it started. So, so look at this circle that you see on the left side, and it has been divided into 5 equal areas like this. If I just draw it like this way, you see each area here is equally divided, and as per the diagram, if 3 of those areas are equally or shaded in this way, we call the areas that are shaded covers 3 out of 5 sections. So this is what we call as a fraction. We write it in this form. We write it in 3 over 5 type of manner, and this area is what you call a fraction. So that is considering this entire circle as one unit. Then if someone asks you to calculate the area of the shaded section, you call it 3 over 5. And if someone says the entire area of this circle is 10 square meters, so square meter is a way of, it's a unit, meter is a unit, and when it comes to areas, it's usually denoted as square meters. It can also be sometimes square centimeters, square kilometers, depending on the area that we are talking about. And if it's a geographical area, it's likely that it is a square kilometer that we are talking about, a circular area. But let's assume the area is 10 square meters. Then the shaded areas, shaded surfaces area is calculated as 10 square meter times, because it's 3 times the 5 units, 10 divided by 5 becomes 2, then the area becomes square meter 6 square meters. If the entire area is 10, obviously this shaded sections area should be less than 10, correct? And that's how the 6 value came in, because the fraction that is shaded is 3 over 5, and we call it 10 times 3 over 5, 6. That's how you call it. So these are the manners that that we use fractions for, to calculate various details and so forth. So let's move on to further sections down here. So similarly, if you look at this square over here, if I this rectangular, and I divide that into equal pieces, and if I just shade one, what is the shaded area in fractions? It's 1 out of 2. 2 equal sections are there, and out of those 2, 1 is shaded, and that's how you indicate the fraction, right? So let's move on to understanding mixed numbers and improper fractions. So you'll come across these terminology in mathematics, in geometry sometimes. So let's understand that as well. Let's look at the 2 circles that you see on the left side. So there are how many sections? 1, 2. If I calculate again, 1, 2. These sections, if I draw it this way, and it's been divided like this, this, and this. Similarly, if I just do it this way, so 1, 2, 3, 4, 5, 6, 7 sections are there, rather 8, right? 1, 2, 3, 4, 5, 6, 7, 8, and all of these are shaded. And In the other one, only 3 equal sections are shaded and remaining ones are not shaded. So how do we represent the shaded area considering this entire circle, one circle as one unit? So the way that we write is, now you have 1 here, and this section, of course, 3 out of 8 is shaded. So if we just add up those 3, we normally indicate this in this way, and this methodology of indication is called mixed numbers, right? It's usually called the mixed numbers, but you can write it in improper fractions in the sense the numerator becomes a higher value than the denominator, then it becomes an improper fraction. So the way to write that is considering each, now out of these 8 over 3, if we keep calculating these individual pieces, 3 pieces are shaded here, and in this section 8 pieces are shaded, right? So if we just add up those 3 and 8, which is 11. So 11 pieces out of 8 in one of this unit is shaded. So basically these two becomes equal. So we can write 3 over 8 as 11 over 8 as well. It's easy to calculate this. You can basically, if someone gives you this mixed number, how do we deduce the improper fraction, is you keep this 8 as is, which is what this is, and to get this 11 you had to multiply 8 by 1 and add 3. So 8 times 1 is 8, and then adding 3 to 8 gives you 11. So if someone gives this fraction, this mixed number, to make it the improper fraction, we have to keep the 3 there, and above 3 we have to calculate 3 by 2 is 6, and then add these 2. So 6 and 2 is 8. So this is the improper fraction of the mixed number. And then in mathematics you will come across situations to add fractions and so forth, right? So let's say you have a situation where two fractions need to be added like this: 1 over 5 plus 3 over 5. How do we calculate this? It's easier way is, because these two denominators are same, we can keep it as same, and then we can add these two. 1 plus 3, 4 over 5 is the answer. You can only do these two additions if the denominators are equal, otherwise you can't do that, right? So if I say, for example, 1 over 5 plus, let's say, 3 over 4, if you try to make it like 5 plus 4 is 9, 1 plus 3 is 4, this is wrong. So don't do this thing. So to calculate, add these two numbers, these two should be same. And even in that case, we didn't add 5 and 5 as 10, and we didn't put 10 there. So we just brought 5 as is, and we just add up the numerator part, 1 and 3 together, and made it 4, and 5 remains as is. And why is it so? Let's see it in graphical form, then you will understand better. Okay, so the 1 out of 5, let's draw in a graphical way. So for example, let's write these two. Let's assume these two are equal squares. I'll just make it this a little bit bigger, and I'll divide this into 1, 2, 3, 5 sections, and 1 out of that is colored. And here 1, 2, 3, 4, 5, and 3 out of these are colored. So now if we consider all of this together and just interpolate all of this, considering these 5 as one unit, and then it's about bringing these three boxes here. So it will be like I'm coloring all of this. Then how many boxes are colored? 1, 2, 3, 4. These 4 out of the 5. That's how 5 or 4 over 5 came as the answer. Fine. And sometimes you might also get deductions. So let's do one of that next. Right, let's find out this section that you see on the right side. Right, so 1 over 5 plus 4 over 5 minus 2 over 5. It's pretty easy to do now. You know that when denominators are the below part of the fraction, if they are the same, you can just do the normal calculation on the numerator, just like 1 plus 4 minus 2. So 1 plus 4 is 5 and 5 minus 2 is 3. The answer is 3 over 5 for this particular calculation. But things become little complex if the denominators are not the same. So let's look next on how to make such calculations. So before finding out that, let's get one of this number, 3 over 7. Now this fraction, you can write it in the same way. Now let's say 3 over 7 is like, if you have this entire box divided into 1, 2, 3, 4, 5, 6, 7, and let's assume that these 3 are colored, then that is what this particular thing is about. But what if I just divide this also into 2 different pieces, and each piece is divided into 2? So then all together there will be 14 boxes, and these colored boxes, now earlier there were 3 boxes that were colored. Now I divided into 2, which means I created 1, 2, 3, 4 and 5, 6 boxes colored now, so which means 14 over 6. So basically 3 over 7 and 14 over 6, sorry, 6 over 14, both are the same. So how can we deduce this from this? Basically you can multiply 3 by 2, you got 6, and 7 by 2, 14. So same thing, if you just multiply this by another 2, 12, 14 by 2, 28. All of these are same fractions. So this is going to be helpful for us to calculate additions of fractions if the denominators are unequal. So let's look at that next. Okay, so let's calculate this. So what you see on the this section, let's do an exercise right away. Can you see this? Maybe I'll just do the same here, this particular thing. So 1 over 4, 1 over 4 plus 2 over 3 minus 5 over 6. Now you clearly see the denominators are not equal. So we need to make the denominators the same value. So the best is to see what's the common denominator all of these denominators can come into. So looking at this, if you know mathematics, you can right away think 12, right? So you can write everything out of 12. If 1 over 4 can be written as 3 over 12, because now to make 12 from 4, you had to multiply 4 by 3, this one. Then I had to multiply 1 by 3 as well. That's why this came. That's how that came, right? And similarly, 2 over 3, to make 12 from 3, you have to multiply 3 by 4. So similarly, 2 by 4 is 8. So 2 over 3 is equal to 8 over 12. And subtracting 5 over 6 Now 6 times 2 is what? 12. So that's what brought this. So then I have to multiply 5 by 2 as well. So 5 times 2 is 10. Now you can easily calculate. You can bring 12 and just do the normal calculation. 3 plus 8 minus 10. So 3 plus 8 is 11. 11 minus 1. 11 minus 10 is 1. So that's how this value of 1 over 12 was deduced there. So it's pretty easy, right? Next thing is, now we learned adding fractions and subtracting fractions. So remember, when you add and subtract, you need to make the denominator of those fractions into an equal number, just like what we saw in this example. You see, now in this case denominators are not equal, so we made it equal, and we found 12 is the common denominator, one of the common denominators. We call it the lowest common denominator, and you can make it to any other denominator also, and you can calculate and then simplify the fraction, but the finding the lowest will be the easier section. Now multiplying is even more easy. So let's figure out multiplying. Let's say 3 over 4 times 1 over 3. To calculate this, it's pretty easy. It's not as complex as doing additions and subtractions. It's just that you have to multiply the numerators and denominators, and you just have to multiply 3 by 1, which is 3, and 4 by 3 is 12. And then you can simplify this. 3 over 12 is equivalent to, just like you can multiply both denominator and the numerator, you can also divide it. So you can divide this part by 3 and this part by 3. 3 divided by 3 is 1. 12 divided by 3 is 1 quarter. So it's like, now if you just look at this section, how can we graphically think about this? 3 over 4, I can write it this way. Now this part is, these two parts are covered, and then telling, out of 3 over 4, the colored section, or shaded section, if 1 over 3 means if just find just one of those 3, and that means these two sections won't be colored, only this section will be colored. And then we have 4 sections, and out of 4 only 1 will be covered, so which is what this number is. So it's easy to think in that way as well, but most of the time when you do fractions, you don't have to think in that way, and once you know the formula and how you do those functionalities. Let's find one more example. So let's do one for mixed numbers, as you can see in the example 2 on the left. Right, so in the example 2, you have this number. So the way to calculate this is, first of all, you have to convert these mixed numbers into improper fractions. The improper fraction for this part is 3. You have to bring the same, and then you have to multiply 3 by this number 1 and then add 1, so which makes it 4. 3 times 1 is 3, and add this one, which makes it 4, multiplied by 4 here. You have to write the same 4 here. To find the numerator, you have to multiply this 1 here by 4. 4 times 1 is 4, and add this 3, which will make it 7. And then multiplying this is quite easy. So basically, when you do this kind of multiplication, when you have 4 here and 4 here in 2 cross paths, you can cut it off and then make it 1. And then this basically becomes 1 times 7 is 7, and 3 times 1 is 3. So 7 over 3 is the answer in improper fractions form. But if you write it in mixed numbers, this will be 2. So 3 times 2 is 6. 6 and 1 is 7. So you can write it in this form. Right. So then next is division. So how do we calculate division of fractions? Right. So taking an example here. So here you have 4 over 3 divided by 2. So this way, how you do this is 4 over 3. This division you see here, you can convert it to a multiplication, and then finding, you make this upside down, or you find the reciprocal of 2. The reciprocal of 2 is half, right? Reciprocal of 3 is 1 over 3. Reciprocal of 4 is 1 over 4. So reciprocal of 2 is 1 over 2. So I just wrote this for the sake of writing. And now we can do this calculation as 4 times 1 is 4, 3 times 2 is 6. This is basically 4 over 6, or you can divide 4 by 2, then you get the answer 2, then 6 by 2 is 3. So it's 2 over 3 is the answer. And let's do a few more examples here. So I'm going to take this last example, fourth question, sixth one, and let's figure that out. Right, so I'm going to write 1 over 2 plus 2, 4. So how to calculate this? Find the value of this. So these are mixed numbers. We have to convert this to improper fractions. So you can write this as 2 times 1 is 2, 2 and 1 is 3. So 1.5 can be written as 3 over 2. And this one, 4. 4 times 2 is 8. 8 and 1 is 9. You can write it this way. And minus 3 times 1 is 3, and 3 and 2, 3 plus 2 is 5. So you can write it in improper fractions in this form. And now you see the denominators are not equal. So we have to make the denominators to an equal part. So it's easy to see that the common denominator for all of this is actually the value 12. So to make 12, to write 3 over 2 in the form of 12th fraction, so you have to multiply by 6. 2 times 6 is 12. Likewise 3 times 6 is 18. 4 times 3 is 12. Then likewise 9 times 3 is 27. And then minus 3 times 4 is 12. Likewise 5 times 4 is 20. Now you can easily calculate this. 12, 18 plus 27. 18 and 27, how much? So you can calculate that here. Plus 18 and 8 and 7 is 5. Then 1 over, and which is 45. 45 minus 20 is 25, right? So the answer is 25 over 12, which you can write in mixed numbers in this form. Correct? That's the answer for that question. Right, I'll leave the next examples as an exercise for you. Okay, so sometimes in mathematics or in usual verbal conversations, you get this word of. How much is 1/2 of 100? Then we know the answer is 50. Right? So you can write it in this way. 1 over 2 of 100 is 50. So simply this of can be converted into multiplication. So that's what makes this. So half of 100. So you divide 100 by 2. Answer is 50. So 1 over 3 of, someone say 1 over 3 of 9. You can write 1 over 3 times 9. 9 divided by 3 is 3. So that's the answer. So that is how you convert the word of. So remember that word of is simply in mathematics, and fractions can be converted into a multiplication. Now see on the left side something that you can graphically perceive, this off term, and you see on the left side 4 over 5. Something you can draw it in this form. So all of these sections are colored. So then we write it in 4 over 5 form. So when someone says 1/3 of 4 over 5, so that means out of these colored sections you have to divide it into 3, 1/3 of that, and then in the total form it's just one of this is colored. That is the 1/3 of it. So if you consider the entire squares, and you see in each row you find 1, 2, 3, 4, 5 squares. Likewise, you have 3 rows, 1, 2, 3, this row, and this row. So which makes it 15 rows, and out of 15, 4 is colored. So this is how graphically you think of. So basically, in our earlier methodology, this is calculated as this. So 1 times 4 is 4, I'm just writing it here. 3 times 5 is 15, which is the same as this. So that is how you graphically understand the fraction of another fraction. Okay, so moving on. So let's try to do an example here. So I'll take the third example. A person who owns 3 over 5 of a land, or 3/5 of a land, gives 1/3 of it to his daughter. What is the portion received by the daughter as a fraction of the whole land? So he owns 5 over 3. So he owns this part, and now he is giving, so this is calculated as 5 over 3. Now he is giving out of this 3, he is giving 1/3 of this 5 over 3. So which means, again, just like the previous calculation, so he's just giving one of this. If I divide this into 3 sections, is just giving one out of this. So he's giving this. So out of the all, so then you have to find equal sections. So then you find 15 squares all, and out of those 15 he is only giving 3. So you can simply calculate it as 1 over 3 of 3 over 5. So which you can make it in this way, 3 over 15. You don't even need to draw it this way, but because of the terminology and the knowledge of fractions, now you can just calculate it in this way. That's pretty easy. And simplifying expressions with brackets according to the BODMAS rule. So that's something that you need to know very well in calculation. So let's understand what's BODMAS is. So BODMAS stands for brackets of division, multiplication, addition, and subtraction. So when you have any mathematical fractions or numbers or whatever, you have to abide by these order. So whatever is within a bracket should be calculated first, and then off should be calculated next, and division should be calculated next, and multiplication, addition, and subtraction in that order. So let's see an example. I think that's the easiest way to look at something. So let me go to an example right away. So let's try this. Question number 1, exercise 3.2, question number 1, part 5. I'm going to use that first. So it states 3 over 4. Let me just zoom it in. Then division. Then you have brackets. Okay, so first thing to do is brackets, right? So according to BODMAS, I'll just write it in this way. First you have to do the brackets, so whatever within the bracket. So let's do that first. But while doing that, you can also convert these mixed numbers into improper fractions. That's fine. So 4, this part can be written at 4 times 3 is 12, 12 and 3 is 15. And then you have the division. And then within the brackets, convert these mixed numbers into improper fractions. 2 times 2 is 4, and 4 and 1 is 5, plus 4 times 3 is 12, 12 and 1 is 13. And then still go on and calculate the things within the brackets, right? So 15 over 4 divided by this part. Now you find it's an addition, so you have to make the denominators into equal numbers. So it's easier thing is to make this 2 into 4, and so that we don't need to change this. So 2 times 2 is 4, likewise 5 times 2 is 10. So we can add it this way, and this will be 15 over 4 something went terribly wrong there. So 15 over 4, I'll write it this way, 15 over 4, this was 4 over 10 plus 4 over 13, right? So then there's division here, so I'll make the division here. 4, 10 and 13 becomes 23. And I'll take this calculation here. Then 15 over 4, then this division becomes multiplication, and then we had to make it to a reciprocal like this. Then we can take this off, then the answer is 15 over 23 is the answer. Let's do one more. So let's go into this last one, 8th one. It's pretty easy. So 5 over 6 divided by 7 over 18 of 2 over 3 by 3 over 4. So the first thing to do is off out of BODMAS, right? There are no brackets here, so we'll do this part first. So 5 over 6 division 7 over 18 times 2 over 3 times 3 over 4. Right, so when this comes, you can do this part, but now it has converted into a multiplication. So when there are multiplications and divisions, actually those can be done in any order, even though it's division comes first and multiplication comes second. So you can do this as 5 over 6 times 18 over 7 times 2 over 3 times 3 over 4. Now this becomes quite easier, so I'll just take this off. Then 18 divided by 6, this one is 3. Then it's easy. 5 times 3 is 5 times 3 is 15. 15 times 2 is 30. And divided by, there's 1 here, there's 1 here. 7 times 4 is 28. And then we can simplify this. You can divide those two by 2. So 30 divided by 2 is 15, and 28 divided by 2 is 14. This is the answer for that. Next up, I would like to conclude this particular section with this last bit here. It's an interesting question, so that's why I wanted to conclude with that. So let's read it carefully. That is just for further knowledge. It's not a question. So this says, this is the this is only for your knowledge and will not be checked in exams. Recall the figure on page 28. But don't take those words in textbooks, but just study what is there. So now we know the shaded fraction is 1 3/8. If a circle is considered as 1 unit, so this can be written as, of course, so earlier we saw this, so this can be written as 11/8. Fine. If both these circles are considered as 1 unit, then the shaded fraction is 11/8. That is 11/16, of course, if both are considered as 1. So that means you have this circle, there are 8 here, and there are 8 here, and if both of these are considered 1, there are 18 equal units. Sorry, 16 equal units, 8 and 8, 16. And out of these 16, how many are colored? 8 are colored here, and 3 are colored here. So that's why 8 and 3 becomes 11. Answer is 11/16. But considering one circle as a unit, the fraction becomes this instead of this. So this 11/16 becomes the fraction considering both the circles as 1 unit. So that part I believe you understand clearly, right? So now further continuing here. Now in the above diagram, if one square is considered as 1 unit, the shaded portion is, yes, so let's figure that out. So one square, now this is a square, there are 3 squares, and each square is divided into 4, and here 3 are colored, here everything is colored, here everything is colored. So if each square is considered as 1 unit, how many are colored? 1 and 1, 2, and here 3/4. So this can be written as 2 3/4, or in improper fractions, out of these 4 units, how many are colored? How many strips are colored here? 4 here, 4 here, 8, and 3 here, 11. That is how 11/4 came by. So now here the question is, the question number A, what is the shaded fraction if all 3 squares together are considered as 1? So to answer that, we need to understand how many total squares, how many total rectangles, equal rectangles are there. Now 4 is here, 4 is here, 4 is here, so 12 rectangles are there. And out of those 12, how many are colored now? 11 are colored. So the 11/12 is the answer, as you can see in the answer down below. So second question, question number B says, what is the shaded fraction if half a square is considered as 1 unit? So how to deduce that? Let's figure that out. So they're saying half of this square. So half of this square, the half of this square can be drawn as these two. Half of this square can be drawn as in 2 halves, right? And this is divided into 2, this is divided into 2, this is divided into 2, this is divided into 2. This half in this way, actually half is divided in this way, right? Here the half, there are 2 sections in those half, 1 and 2. There's 1 and 2 here as well, like this. Now this unit is 1, right? And we know both of these are colored because this section was colored. Both of these are colored because the bottom section was colored. This was also colored. This was also colored. This was also colored. And here only 1 is colored. So now considering this as 1 unit, how many are colored? 1, 2, 3, 4, 5. 5 is colored. 5 are colored. And out of this unit, only half is colored. So that is how this 5.5 came by, and that's the answer for the colored portion considering half of the initial squares as 1 unit. So that's the answer. It's an interesting question, so think through that, and this brings to the conclusion of this chapter and this lesson, and I hope to see you in another lesson very soon. Please subscribe to this channel for more mathematics videos like this. So these are fundamental ones for grade 9, and of course we'll be going into advanced mathematics over later stages of these videos in this channel. So keep a tab open on this. I'll see you in another post very soon.